In this video, we'll talk about graphs of quadratic functions and what that would be. For starters, a quadratic somewhere in the equation has an x squared term. So if we look at the equation x squared equals y, it's going to be the shape of a parabola. Because if we do a t-chart, well, we'll have 0, 0, 1, 1, 2, 4, 3, 9, and so on and so forth. It's going to just take off. And if we look at the negative side, well, a negative squared results in a positive, so it'll just flip and be the same side of the curve, and it's going to result in this very sharp U, also known as a parabola. And we'll talk about some characteristics here. In particular, a parabola always has a vertex, and sometimes it could even look like so, resulting in a maximum. So determining whether we have a minimum or a maximum will be one of the first things that we talk about. So let's talk about standard form. So standard form of a quadratic is going to look like y equals ax squared plus bx plus c. And if you look at the bx plus c, well, this is just the linear expression. So it kind of looks like the mx plus b, if you think about slope-intercept form, where really a, b, and c are all given values. And there is another type of format for quadratics. However, this one can do a lot for us. We're going to focus on it first. For instance, if we look at a, if a is positive, otherwise greater than 0, we're going to have a minimum. In some way, shape, or form, our quadratic is going to have this kind of shape to it. If we have a being less than 0, if it's negative, we're going to have a maximum. It's going to look, well, like the upside down version of it. So that's one indicator, one use. We'll also talk about vertex, which we can find pretty easily with this format. So let's talk about vertex. So one method to finding the vertex, if we still have our standard form, is we can say the x-coordinate of the vertex is going to equal negative b over 2a, where we're talking about this b and this a. Now, I could go into the y behind it. It will require some calculus. So for the intents of this video, to keep it short, I'm not going to go into it, but there is a good reason as to why this formula comes in. Now, if we want to figure out the actual coordinate, the y value, all we have to do is plug in this value after we've solved or simplified this expression. Now, the axis of symmetry, if you think about a parabola, it has that line of symmetry, so the axis of symmetry also is that x-coordinate. It's the middle of our parabola. So let's do an example really quick here. So if we're looking at this, technically, my a is a 1. So a is 1, and b is negative 2. Now you got to be very careful with your signs here. So we're saying x is equal to negative b, so negative of negative 2, over 2a, which in this case is 1. Which means that my x-coordinate is 2 over 2, which means it's 1. So that tells me the x-coordinate. Now I'm looking for the entire vertex coordinate here. So I also need the y value. So in order to do that, I'm going to take this 1 value and I'm going to plug it back in everywhere I see an x in here. So let's do that really quick. So y is going to equal 1 squared minus 2 times 1 plus 4. Well, 1 squared is 1, minus 2 is negative 1, plus 4, so y equals 3. So our vertex coordinate is going to be 1, 3. So that's one example of how we can find the vertex coordinate without having to graph or plot a bunch of points until we essentially get lucky. And this example worked out nice. However, as you can imagine, many of these do not have nice vertex coordinates. So it'd be very difficult to guess. This way, however, will always work and it will always be precise.